Hello, everyone. My name is Priscilla Adenuga. I'm a linguist working at the intersection of language, structure, low-resource languages, and natural language processing evaluation. So what I want to argue today is a simple but I think consequential claim that low-resource languages are not only difficult because they lack data, they are valuable. They are genuinely valuable because they expose assumptions that are hidden inside our labels, inside our benchmarks, inside our annotation schemes, and our evaluation metrics. Let me start with something that is going to look very easy. So here is the task. You are annotating a data set. You see the phrase, old friend, and you need to label the adjective old. How would you label it? So would you label it as age, meaning the friend is elderly? Or will you label it as duration, meaning the friendship has lasted a long time? So can we quickly show our hands? How would you label it? Age, duration? Aha, interesting. Some of you said age, while some said duration. Maybe some are still deciding. But here is the thing. Both answers are valid. The phrase is structurally simple. 2 words, but the interpretation is not simple at all. It is genuinely ambiguous. And both readings are fully available in the grammar of English. So now imagine, you are building a benchmark that assigns exactly one correct label, one right answer, one ground truth. That decision to collapse a real ambiguity into a single label is not a neutral technical choice. It is a theoretical claim about what language means and how language works. So, and the tension between the complexity of actual language and the simplicity our benchmarks assume is what this entire talk is about. So let me now state the central argument of the talk. When we discuss low-resource languages in natural language processing, the conversation usually focuses on missing data. We need more corpora. We need more annotations. We need more benchmarks. And those are important challenges. But I want to argue that low-resource languages reveal something else. They reveal representational assumptions about how language, assumptions about how we label data, assumptions about how we tokenize language, assumptions about how we annotate meaning, and how we evaluate models. So these assumptions exist in every natural language processing pipeline. So the difference is that in high-resource languages, scale often makes them difficult to notice. Language datasets can make inconsistencies appear less important. For instance, large benchmarks can make hidden assumptions seem stable. But in low-resource settings, there is nowhere to hide. The assumptions become visible. And once they become visible, they become informative. That is why I describe low-resource languages as stress tests, not because they break our systems, but because they reveal where our assumptions are weakest. Let me show you what one of these hidden assumptions looks like in practice. So consider this sentence. Not surprisingly, the results were positive. Now, imagine a benchmark that labels this as negative. At first glance, that may seem reasonable. After all, the sentence contains the word not, which is a classic negation marker. So the benchmark dictates a well-known cue for negation and assigns negative polarity. So from the perspective of the benchmark, the decision is perfectly consistent It is framing the speaker's expectations. So we arrive at an interesting situation. The benchmark is internally consistent, but it is wrong. Not because the model failed, not because the data is noisy, but because the evaluation framework collapses a distinction that matters linguistically. So what looks like a model error is actually an evaluation problem. And that distinction is important because if the benchmark cannot represent the phenomenon correctly, then the benchmark score becomes much less informative than we think. And if we can miss distinctions like this in English, what happens when we move into low-resource languages? Now, let me show you something from Oge that has been with me for years. Oge is a language spoken in southwestern Nigeria. Oge is not my mother tongue. I speak Yoruba. Yoruba is also spoken in Nigeria, but Oge is my research language. So I've been working with Oge for more than 20 years. So this phrase here, ihoho eswe, one surface form, two words, but two structurally distinct available readings. So the first reading is adjectival modification, the White House, or a White House. So here, ihoho functions as an adjective modifying eswe, which is the house. The second reading, a nominal construction, whiteness of the house. So here, the semantic relationship is different. Whiteness is foregrounded as a property, almost as an entity in its own right. Now, I want to say again, ambiguity is not unique to Oge. Ambiguity is not unique to Yoruba, the language that I speak. Ambiguity is not unique to English. Every language has ambiguity. English has ambiguity. But what makes this linguistically significant is structural ambiguity, where the same surface form supports two different underlying structures. So both readings are fully grammatical. Neither is derived, neither is marked, neither requires additional context to license it. They are both just there. So when you try to build a benchmark on top of this, you face a choice. You pick one reading and call it correct. But the linguistic system itself does not make that choice for you. When you force a single label, you are not capturing what the language does. Rather, you are projecting a categorical decision onto a space that the language leaves genuinely open. So you are asking a question that the language does not have an answer to. So this is what I mean by representational assumption, not sloppiness in the data, not noise to be cleaned, but a mismatch between the expressive structure of the language and the expressive structure of the annotation scheme. So with those examples in mind, let me now introduce the 3 stress tests I want to propose. Diagnostics you can run on any natural language processing data set to surface hidden representational assumptions. Stress test number 1, label stability. So the question is simple. If you give this item to 2 independently trained annotators, would they make the same decision? Old friend. One annotator says age, another says duration. Both are defensible, both are linguistically valid. One annotator writes White House, another writes whiteness of the house. They read the same surface form, yet they arrive at structurally different analyses. So in high-resource natural language processing, annotator disagreement is typically treated as noise. You compute inter-annotator agreement, you adjudicate the disagreement, you pick a winner, and you move on. So the goal is to arrive at a single clean label for each item. But I want to suggest a different interpretation of persistent disagreement. When 2 trained annotators people who understand the task, people who have read the guidelines, people who are trying to get it right. When they consistently arrive at different answers, they may be telling you something true about the phenomenon. So, not that one of them is wrong, but that the phenomenon itself is genuinely underdetermined by the annotation scheme. So in that case, the disagreement is not noise to be resolved. Rather, it is linguistic evidence to be preserved. So when you run label stability checks and find low agreements, don't just average it away. Ask why, because the answer might change what you build. The second stress test is guideline robustness. So the question is simple. So do our guidelines survive contact with real language? Because guidelines always look neat on paper. Then people start using dialect, they switch between languages, they borrow words, they spell things differently, and suddenly the categories we designed are not quite as stable as we thought. So the lesson here is this: real language is always messier than the guideline. And low-resource languages make that messiness impossible to ignore. So the third stress test is about numbers. So does your score actually change when your task definition becomes more linguistically precise? Binary polarity. The model detects not and assigns a label. Clean, very fast, 91%, publishable. On the other hand, we introduce discourse-aware polarity. Same model, same data, but now we are asking whether it actually understands the sentence and not just the item, negation marker in the sentence. So then the score drops to 67%, 24 points gone. And the model did not change at all, right? So what changed is what we ask it to demonstrate. So 91% means good at the task, as I have defined it. It doesn't mean my model understands polarity, for example. So what do we actually do differently? I have listed 5 items here: data collection, documentation, annotation, review, and evaluation. But because of our time, I'll talk briefly about documentation, annotation, and evaluation. Documentation. Write the theory down. When you write annotation guidelines, you are not just writing rules. You are encoding a theory of the language. Make that theory visible. Invisible theory, as we all know, is dangerous theory. Annotation. Prescribe the ambiguity. If the language does not draw a distinction, do not force one. Create an underspecified category. Your models can learn to undo it, but only if you give them the signal. Evaluation. Separate the cue from the meaning. Dictating the word not, for example, and understanding what a sentence actually means. Those are different things. Your metric should be able to tell them apart. That is it. Not more data, better frameworks, more honest ones. In conclusion, stress tests do not exist to break systems. They reveal where robustness is only apparent. They reveal what our systems assume about language. So, I want to leave you with this. If a benchmark only works when language behaves like English, then the benchmark is measuring its assumptions as much as the language itself. Low-resource languages are often framed primarily as a resource problem, so we need more data, we need more annotations, we need more compute, we need more coverage, and yes, those things matter. But I have tried to argue today that low-resource languages are also something else. So they are diagnostic environments. They are the places where annotation categories become unstable, where benchmark assumptions surface, where evaluation metrics stop tracking what we actually care about. So in a well-resourced settings, say English, Mandarin, Spanish, these problems exist. They are just harder to see. The data is plentiful enough that the inconsistencies average out. So the model is large enough that the mismatch is papered over, and we call the result progress. So low-resource languages do not allow us that comfort. Oge, for instance, or the language that I speak, did not teach me that natural language processing is broken. It taught me where to look. Thank you.
Thank you, Priscilla. We have about 2 minutes for questions. Any questions? Let me check the online folks. Okay, great. Thanks so much again, Priscilla Adenuga. Thank you very much. A big round of applause.